Find a function that models the simple harmonic motion where the amplitude equals 21 centimeters, the period equals 9 seconds, and displacement is at its maximum at t equals 0 seconds. Simple harmonic motion is given by d equals a times cosine omega t, or d equals a times sine of omega t. While we're using different variables here, these equations are in the same form as the form shown above when we were studying the transformations of sine and cosine. Notice if we let c and d equal 0, the form is y equals a times sine of bx, or y equals a times cosine bx, which are the same forms for the equations for simple harmonic motion. Recall when c equals 0, there is no phase shift or horizontal shift, and when d equals 0, there is no vertical shift, and the midline is the horizontal axis. Let's begin by graphing the simple harmonic motion. Because the amplitude is 21 and there's no vertical shift, let's mark positive 21 and negative 21 on the vertical axis. The units here would be centimeters. And let's mark off one period on the horizontal axis, which is 9 seconds. And now we'll break the period of 0 to 9 seconds into 4 equal subintervals. Because displacement is at its maximum at t equals 0 and the amplitude equals 21, we know the graph contains the point 0, 21, which is the vertical intercept. And from here, because we have simple harmonic motion, we should be able to recognize the graph is going to resemble the cosine function, and therefore the pattern over the 4 subintervals of one period is max, midline, min, midline, and max. Let's go ahead and graph the function. We should recognize it'll be easier to find the equation using cosine, and therefore the equation will be in the form of d equals a times cosine of omega t. The absolute value of a is equal to the amplitude. We know the amplitude is equal to 21, and because there's no vertical reflection across the midline, we should recognize that a is equal to positive 21. Next, 2 pi divided by omega equals the period, which we know is equal to 9 seconds, which means 2 pi divided by omega must equal 9. Let's solve for omega by first multiplying both sides by omega. Simplifying, we have 2 pi equals 9 omega. Dividing both sides by 9, we have omega is equal to 2/9 pi, or 2 pi divided by 9. Which means an equation that models the given simple harmonic motion is d equals 21 times cosine of 2 pi divided by 9 times t. Be careful here, make sure we have this as a function of t, not a function of x. Otherwise, the homework system will mark the function as incorrect. I hope you found this helpful.